Hey, you may recognize this, as this here is my very simple keyboard interface that I made for day 24 of my shorts series. I'm making this video because I need this keyboard interface to do more, like a lot more. But I also figured some of you may like to see my process as to what goes into making these videos. I would like to produce more YouTube videos in the future, but I figured that this may be the best way to do it for now. So, this thing needs to do a little more, as I said. It can only read scan code, and only one at that. I may need to explain a little bit of where we're at and the goal. But before we do that, I'm very excited to announce that we have our very first sponsor, allpcb.com. If you need a PCB product, allpcb.com is running a promotion right now that is available for everyone. If you haven't ever ordered from AllPCB, with your very first order, you can get your PCB for only $1, which can include free shipping worldwide if your calculated shipping is $30 or less. If you already have an account with AllPCB, there's actually an option for you as well. For every new user that you invite, when they place their very first order, you'll get a $30 coupon. The amazing news is that the new user is eligible for the $1 first order. They get a $1 PCB with free shipping, and you get a $30 coupon for your next order. You can refer up to 10 people for a total of $380. If you're interested in these big savings, I highly suggest that you check out the links in the description below. Thank you again, AllPCB, for sponsoring this video. Alright, so let's look at how all of this is working so far. While I'm getting this set up, I wanted to say that I just love learning about how all of this cool old tech works. I didn't even know how a PS2 keyboard worked just 4 weeks ago. So just reconnecting with all this older tech is just mind-blowing and amazing at the same time. Alright, so we're all set up here. When I press a key on the keyboard, we get back some data on the register. These 11 LEDs here represent a packet sent from the keyboard. You will often hear this called a scan code. If we look at just the green LEDs, we can identify what key we just pressed. As you can see, we have 00110011, or 33 in hex, which according to this paper here is an H. If we press it again, you can see that it stays the same. Now look at this. When I hold left shift, we can see that scan code pop up. It's actually flashing. Look what happens when we press that same key as before while holding shift down. It's still the same scan code, same data, same letter. When I release shift, we see that shift's scan code pops back up on our register here. What we can observe is that every key on the keyboard is assigned a code. Holding shift doesn't actually change what that code is. I didn't make that character capitalized at all, which means our interface must manage all of this. I did want to clarify, scan codes are not the same as ASCII. However, our end goal for this video is that the keyboard outputs ASCII, including capital and lowercase letters. A complete but still simple keyboard interface. So, how can we go about doing that? Something that you may not know is that the keyboard is sending more than one scan code when a key is pressed. There's a lot of information here, but the approach that I'm going is that I only need the last 2 data packets. This means I need 22 bits of data to support. So that is the first thing that I need to add. Here we are. All I needed to do was add one more shift register. Half of this register wasn't even being used. Let's test this. When I press a key, let's do H again, we can see what is called our break code. This includes the data from our make code, which is the data for the key that was pressed, which is on the left here. And on the right, just lets us know that we let up from that key. That is the part that makes this a break code. This is actually an important feature, as I would like for the output to be 0 when we aren't pressing any keys. Let's now analyze this with Shift. When I press Shift, we can of course see that scan code, but when I press H again, we can see that for a moment, break code is not there, but Shift is. We would know that H should be capitalized now. If I let go of Shift, then we have our break code. The reason I don't need the break code for the middle keys is because we are technically still pressing a button, and it's helpful to know that we are pressing Shift still. I mentioned that we're going to convert the scan code to ASCII. I should probably explain how I plan on even doing that. Ba-ba! EEPROM! You can do some really neat things with EEPROM. The idea on how I'm going to make this work is that I'm going to program the ASCII character on the EEPROM at the address that corresponds to the correct scan code. For example, when I press H, I can program address 00110011, which is the scan code, to output lowercase h, which would be the ASCII equivalent. And I can do that for all the numbers, all the special characters, all the lowercase, uppercase, all the above. Now, we're left with Shift. How can we make letters uppercased when we're holding Shift? We know that when I'm holding Shift and I press a key, that key plus Shift is shown as scan codes. This had me stumped for a little bit as to how I can even make a scan code for Shift translate to the EEPROM when I only have 15 address lines. I'm basically just one short. That also need to do this for the break codes and even a special character which I haven't mentioned yet. Then it hit me. I can configure a few AND gates to condense 8 bits into a single bit. That's all I really need, right? Shift is on or off. So if Shift is off, the address lines are the same. When Shift is on, the address lines can still represent that same key, but they're shifted, and it will be that uppercase or special character. This will actually be the solution for the other special codes. I figured that I can just use the same technique as Shift for the break codes and the column of special keys. I will program the EEPROM to use zeros everywhere on the addresses that have the break codes enabled. For the special characters, they actually all share the same code, 0xE0, or just E0. So that would be pretty easy to configure as well. I guess the first thing that I should assemble is the shift check using AND gates. You can kind of picture these as a comparison. Anywhere in the binary code that contains a 0, I'm just going to manually invert these. I decided to use a NOR gate for the zeros and a normal AND gate for the ones. After I connect all of these, if I feed the shift scan code through, the output combined will be a 1. Alright, I'm going to go ahead and test this with just one LED here. I'm going to hold shift. There we go. And now let's press a key. Did you see that flash? That means it worked. I saw that LED flash on. Technically, I'm not done with the shift as there's still the right shift key too. I'm going to go ahead and skip this for now and move on to the break code and the special characters. Alright, we actually have a lot of this done now. The only thing we need to do is program the EEPROM and then connect it all up. The programming part will take some time. I actually kind of found this part enjoyable. I really enjoy programming, and this is basically a program. A weird program, but still is a program. It actually took me a while to figure it out. I created this system here. I made this Google Sheet that had all the associated codes, and all I had to do is pray that I did not miss any addresses. I like to listen to my Spotify playlist when I do anything like this. I try to convince myself that I'm programming for an old IBM computer or something, listening to the late 70s radio. Alright, I guess it's time to program it. This seems to have worked. Let's test it with my EEPROM tester. Let's go ahead and put in the number 5 as a keyboard scan code, and let's see if we get back 5 in ASCII. Well, according to this paper, we should be golden, so I just need to connect the keyboard interface to the EEPROM now. After some debugging, I realized that I fed all these lines in backwards. I fed the most significant bit to the least significant bit, and it's time to rewire this. Well, time to plug this in and pray that it works. Okay, I'm gonna go through and test everything. Preferably, I would like to connect one of these LCD screens up, but I'm tired of building stuff. Although you can expect to see an LCD screen on this computer somewhere in the near future. But let's go through a few keys. I'm going to show you guys a few keys working, and then after that, I'm just going to cut it. I am sure that you are very tired of seeing all these time lapses. Whew, that was a long journey. I would love to hear your thoughts. Do you want to see any more of these videos? I really do want to transition from posting mostly shorts to more full YouTube videos. I feel that I can fully express my work here. If you agree, subscribing or commenting is a great indication that I should keep doing this. I can't imagine that this will be my last video going through the process, but I won't really prioritize it if there isn't great feedback, as this video did take me a long time. I do want to say thank you again to the sponsor of this video. It really is a huge motivator when there's a sponsor behind these videos. I didn't even think it was possible with my level of status. I hope you guys enjoyed this video. I'll see you guys again. Bye-bye.